Welcome back to the Art of Math. Quick question for you guys. Let me know in the comments if you prefer the piece of paper or the board. Okay, so today we're going to talk about finding the vertex and axis of symmetry of a parabola or quadratic equation. Now, if you remember, we were doing the quadratic formula, deriving it, understanding it, using it, and this is just a natural mathematical progression. So one of the questions you might ask is, once you have these parabolas, which correspond to quadratic equations, how do we find these special points, like these center right here? How do we find where this is symmetric? So let's go over the definition. What is an axis of symmetry? It's this line, specifically the x value. So for example, x equals 5, where this line cuts the parabola symmetrically in half, where you could fold it over itself. Same thing in this one. Now, whether it's right side up or upside down just depends on your a coefficient, a number, whether it's positive or negative. Now, what is a vertex? It's very related to the axis of symmetry. Once you have your axis of symmetry, which is an x value, you just plug it in to your equation, and then whatever the y value comes out to be, that gives you this point. So that's going to be an xy pair. So for example, let's say this line came out to be x equals 5, then you would plug in 5 into your equation for x, and whatever y was, let's say y turned out to be -2, then this point would be 5 comma -2. All right, and that will be your vertex. So let's go over how do we find the axis of symmetry and the vertex. So there'll be two methods. The first one will be the quadratic formula, and the second one will be completing the square, which I've called CTS. Okay, so the quadratic formula, if you notice, we have two solutions here, the plus and the minus. And if you take a look at the parabola, you'll notice that this axis of symmetry is right in the middle. So if we knew these two left and right points, we could average them and find whatever's in the middle would be this line. So that gives us the idea of adding our solutions. So if we add our solutions and then divide by 2, corresponding to averaging them, the square roots will cancel. So you'll have a plus square root and a minus square root, so the square root stuff is gone. So then you'll just have negative b over 2a plus another negative b over 2a, which will give you negative 2b over 2a. The 2's cancel, and you'll have negative b over a. Divide that by 2 since we're averaging, and then you have negative b over 2a, which is your formula to find the axis of symmetry. Again, don't just memorize this, understand how we got this by adding up these solutions and dividing by 2. All right, so that's the quadratic formula method to arrive at this. Now you could also use completing the square. This is a little bit more involved, however there is a payoff. The payoff is twofold. A, it improves your understanding, and B, it might actually be a little bit faster for finding the y value for the vertex. So again, this is your general quadratic equation, which is y equals ax squared plus bx plus c, where a, b, and c are numbers. Now we're going to set this equal to 0, and that's going to correspond to trying to find these left and right points. And then what we're going to do is complete the square. So first let's divide through by a, because that's a pesky a term, we don't like it. That's going to make it easier to factor. So now we've divided everything by a, and if you remember from the deriving the quadratic equation video, we will factor this nicely and see what thing squared with an x will get us this. So if we have the b over a and get b over 2a and square it back, we will get the correct x term. However, once you square this whole thing and expand it, you will also get a b squared over 4a squared, which is not this term. And that's why I've copied this term down, but then subtracted the extra garbage you get from actually multiplying this out. So this line does correspond to this line, but this is written in a little more clever way. So if this is confusing, you need to review the deriving the quadratic equation video, as well as expanding and factoring. All right, so why is this useful? Because over here, you can tell that if you plug in x equals negative b over 2a, that will zero this thing out. It's the exact opposite of b over 2a. So what does that mean for us? That means that that will correspond also to this axis of symmetry. So we found this same value from completing the square. Now, how do we know that that's where the axis of symmetry lies? Think about it visually. Here you have stuff with x's, and here these are just numbers. So once you have numbers, this does not depend on x. So here we're squaring a number. So the lowest this can be is 0. If you plug it, let's say the inside is like 5. 5 squared is 25. Let's say the inside is negative 5. Negative 5 squared is positive 25. So that's actually higher. So the lowest this can go is 0 because it's a square. Now, and this would correspond to an upright parabola. If this were an upside down, you would just have a minus sign over here. So this tells us that the minimum value, which is this point, is going to correspond to plugging in x equals negative b over 2a, which is your axis of symmetry. And then the question becomes, well, what's the vertex? What is the actual y value of this point right here? And that would just be this part right here. So if you went the quadratic formula route, you would then have to plug this into your quadratic equation to get that y value. But if you did it this way, this kind of gives you a 2-for-1. So to see what I mean, let's do a few examples. So example number 1, you have this equation right here, this curve, y equals x squared plus 8x minus 20. So there's 2 ways to do this. So one way is, let's just not think, let's just use our little formula of x equals negative b over 2a to find the axis of symmetry. Here it is. So our b is positive 8, our a is 1. So when you plug everything in, you get negative 8 over 2, which is negative 4. There's your axis of symmetry. Now, you could plug the negative 4 back in here. So that would be 16 minus 32 minus 20, and then you should get negative 36 for your y value. So this would be the actual vertex. Not bad, pretty easy. However, if you went the completing the square route, you can say, let's just have the 8. That's how we get this 4. So it's x plus 4 squared. But 4 squared gets you 16, and we want a negative 20. So how do you get from 16 to negative 20? You subtract 36. So this is our completing the square way of seeing this curve. And from here, it's very apparent that when you plug in negative 4, which is going to be your minimum, your x value to minimize this part's going to be 0, and this part's going to be negative 36. So in other words, by completing the square, it spit out this negative 36 very quickly right over here. So it was a little more annoying to do this, but it sped things up later on. So I encourage you guys to use both methods, see which one you like. Let's try another example. Example number 2. I just did this to make it a little crazy looking. So here we have a negative 2, so this looks kind of scary. The negative just means that, pardon that, the negative 2 means that it's upside down. So it would be something like this, where it's facing upside down. All right, so same procedure. For the quadratic formula approach, we're going to use negative b over 2a. So plug in your b, plug in your a. Your b is positive 5. Your a is negative 2. So don't get lost with the minus signs. So that's going to come out to be 5/4. So 5/4 is going to be that vertical line, the axis of symmetry. So plug in 5/4 for x here to find the y value corresponding to the vertex. And if you do that, it's going to be kind of annoying, and you'll probably get something like this, but you can add it up. This is not simplified. I just wrote this so we can trace this number. Now, let's go the completing the square route, the second option. First step would be, I don't like this negative 2. It's really annoying to deal with. So let's divide everything by negative 2. So we're not dividing it, actually, we're factoring it out. So take out a negative 2. Remember to flip all the signs. That's why I have this really dark minus, because on my first pass I messed it up myself. So that turns into a minus, that also turns into a minus. So if you multiply this back in, you should recover the original. Now if you take a look at this, this looks a little less scary because it's a 1x squared inside. So now we're going to factor this and complete the square the same way we've done in example 1. So we're going to have this further, so 5 over 2 becomes 5 over 4. And everything else pretty much stays the same, except when you square negative 5 over 4, you get positive 25 over 16. But we don't want that extra garbage, so that's why I subtracted the extra thing you get, minus 25 over 16. Now in the end, that negative 2 is going to have to multiply back in, but even so, we factored it very nicely. So at this point, we could tell that 5/4 will be your axis of symmetry, because that's what makes this part 0. So boom, we got the same 5/4. Now for the y value of the vertex, instead of plugging that 5/4 into here, squaring it, it's kind of messy. Here, you could see, okay, when this is 0, what are you left with? Well, you're just left with this, but remember to multiply the -2 in, and so that's going to be +8 and +25/8. So the reason I've left this in this form here is just so you could see how we got these numbers from over here. All right, so that's the second example of how you use either the quadratic formula or completing the square to find both the axis of symmetry and the vertex. And this will be a very useful skill that you should have in your toolbox. I'll see you guys in the next video.